Training only, right?
Yes, 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 yes.
Okay, so okay. Today we actually are going to see starting with DynamoDB part. Okay, so already we have seen Athena. So again, let's repeat this thing what we have seen till now. So we have seen Athena, and we have seen Redshift. Now, if I compare Athena with Redshift, left hand side Athena, right hand side Redshift. Uh, Athena you should only use for ad hoc queries, uh, analytical purpose, not so heavy joins, not so heavy complex conditions. It's and when you want a serverless service, okay. When you want to have very fast, very compute heavy service for analytical purpose, okay. In that case, we should go for Redshift. Redshift can handle any level of complexity. It is easy to connect with your BI tools such as Power BI, Tableau, or visualization, or this quick site. And Athena is not directly available as a connector to some BI tools. Okay, and then if I compare these Redshift with databases such as SQL, Postgre, Oracle. Remember, OLTPs, your online transitional processing things, works well with your databases. Those are supposed to handle row level inserts, updates, and deletes. Okay, this is what we call transactions, like single row level transactions are happening there. Their use case is to handle the live transactions, not to generate reports. Then the use case of Redshift is to help team in analytical part. It is OLAP systems, online analytical processing. Okay, and these are kind of columnar label storage. Here, live data processing does not happen. Here, row by row label updates, deletes, inserts are not optimized. That's why we should avoid these things. We should only use it for our analytical processing. Okay, this is very brief that we have discussed till now. And now the third kind of databases that I'm going to introduce today is uh, DynamoDB. So DynamoDB is coming from a NoSQL database. Okay. So first, let's understand what is NoSQL. Okay. So let's say we have a table where we have name, and then we have employee ID, salary, like very generic table that we see on databases. Okay, let's say we have this table, but in the case if some employees, or we also want to like store some more details about this, or the structure for that particular employee is different, like this employee ID may have salary and also have the details about location. Okay, and we might also have some employee IDs which also have the details about their let's say gender. Okay, and we might also have, okay, are you guys not able to see my screen?
Yeah, I could not able to your AWS screen. Just I can hear the voice alone.
Okay, can you see it now? Still, I'm not on an AWS.
Yeah. Oh, I can see the Excel sheet now.
Yeah. Okay. So I was saying that let's say we have an employee ID, and let's say we want to store its name, salary, and for some employee IDs we might have location also, and for some of them we have gender also, and like that we can have 20 columns. Okay, let's suppose we have 20 columns in this table, and out of those 20 tables columns, let's say only 4 or 5 columns are filled for each and every row. others are kind of empty only. So we are going to be storing nulls for that. So in this case, let's say we are like, in this case, we are storing four genuine records or four actual record and 16 columns with null values. So we are storing more nulls than our normal values. So to avoid this kind of situation, like where we want to store various columns and this okay, and they are not sure to having values, this is the first case. And second case, let's say today I'm getting 4 columns, tomorrow I'm getting 6 column, or it's kind of a web application that I'm having on my front end, and we're asking to submit some forms, and in that kind of like somebody is submitting some columns and somebody is submitting some other details. So our columns may vary. Or if I talk about use case in gaming industry, okay, so nowadays we quite a lot see the games where we have purchasing options, purchasing some suits, some coins, and some other features or those things. So those details are stored behind the scenes in databases only, but not every user is doing same level of activity. So they might have different schemas. So when you have such requirements where your schema might vary, where you have a more null columns, where you want to have very fast processing, in those scenarios, in these or in those use cases, we should look to use NoSQL databases. Now, NoSQL does not stand that no structure query language. It stands for not only SQL. Okay, the first no stands for not only. Not it's like it's not denying that SQL won't be performed. It's saying not only SQL. Okay, we will have some SQL features, but additional to that, we might have some different features. So like all the asset transitions, all the asset properties will be there, and like that. So if I introduce you DynamoDB, so DynamoDB is also uh, one of the NoSQL databases, and it is very heavily used in the industries of gaming, real-time data analysis, logging purpose, and you can say it is also used in e-commerce websites. So these kind of projects or real-time use cases these DynamoDBs have. If you see the features of DynamoDB, it says we have uh, it has NoSQL workbench. That means it can connect with some tools to query this. It is have global table. That means you can launch DynamoDB in one region. We have talked about regions like all the things that I'm launching currently. Those are in Mumbai region, and we can create global tables using DynamoDB. So let's say we have a very famous game that is popular in this whole world. So in this case, let's say I just launch my DynamoDB table in US, and I'm playing that game in India. So obviously I will be having some lag if my table or if my database that is connecting is residing in US. So if I make global tables, like every region has its own table, its own replica, obviously that is going to help me. Like my network is not connecting with US, it is connecting with some DynamoDB table created in India. Obviously it's going to be faster, and obviously in gamings, in real-time applications, we do not want any sort of lags. It is very frustrating. So that is one of the great features of DynamoDB, that we can have global tables. We have data security using encryption at rest. We have point-in-time recovery. I'm going to explain you about more this point-in-time recovery. Basically, it means, let's say we have corrupted our table and we want to go 10 minutes back, so we can just create refer our table to 10 minutes back, and all the latest changes that happened in 10 minutes will be discarded. And then we have on-demand capacity mode. And this means, let's say you have configured DynamoDB to some capacity, and you also enable the auto scaling there. So in the case when maybe in night times, okay, when the users are mostly free, they will be having there will be more traffic on the gaming websites and e-commerce websites. In these times, the capacity of the cluster will increase only for those particular hours automatically, and automatically when it detects that okay, now user are less, it's going to reduce down the capacity. So this is having two benefits. First, it is maintaining the same speed, same performance throughout the session of that particular user. And once that session is over, it is also saving cost by reducing down the configured capacity. And then particular, I'm going to show you practically. This is like just we can write queries there. Okay. And if you see, this is our DynamoDB features, and if we can connect this with S3, we can connect this with Glue, we can have it connected with Kinesis data streams, we can have it connected with CloudWatch and CloudTrails, and many other tools or technologies it can connect with for kind of analysis, visualizations, and some other use cases. So this is the introduction of DynamoDB and NoSQL databases. I'll allow you like just take your time, and if you have any questions, please let me know. Someone has some questions?
Yeah, Jalal, usually NoSQL databases in the SDLC, I mean, in the data processing steps, it will be placed in the first or at the end? On the NoSQL database so far. That's it.
Wait. Okay. It is not necessarily that you have this DynamoDB first of all. Okay, you can skip this completely if you have a batch process. And it is not required DynamoDB. Mostly it is used in real-time use cases, kind of that features, okay? Or whenever your schema is varying a lot. Okay, this is it's you can keep it separate.
Okay.
You can keep it separate from your normal data pipelines. You might have DynamoDB in data pipelines also, but for now you just keep it as a separate feature that is not in your data pipeline of your, at least for your batch data it is not used. For batch, you can say it's start from sources to S3 to using Lambda and other things, and goes to Glue to Redshift. That's what we have in batch.
Right. Like usually in what use cases the DynamoDB will use at client sites usually?
As I mentioned, it's gaming, real-time applications, real-time updates, stock market trading. It is very fast. It is very fast, low latency service, can have a varying schema, e-commerce website. So again, think of an example of e-commerce website. Okay, if you think about this, let's say we have a mobile phone that we are selling. Okay, product is mobile phone, and then we have specifications, and a lot of specification a mobile phone can have. Kind of a various details it might have. It might have 50 columns for that. Okay, and if same kind of table I try to build in SQL, so my mobile phone will have 50 specifications, 50 details, and then if I'm also selling soap. Soap might just have 2 or 3, like it's good to skin, no chemicals, and that's all. Okay, so I'm just having 2 columns, and there 2 are different columns. Mobile will have details about hardware details, camera details. SOAP might not have those columns itself. So when you have this requirement where your columns or your tables are not consistent to the each and every item that you're trying to store in there, in those cases, these NoSQL databases comes very handy. And you can say it's a direct connection between your front end and DynamoDB. You can directly connect this, okay? Or maybe you can pull or push data using some third-party tools. That is also possible. Then from DynamoDB, you can connect, if you want to analyze the data, then maybe you can connect Glue and transform and analyze with Redshift. Or, I mean, pipelines can vary as per your requirement.
Okay. Okay.
I have one question.
Yes.
When you're telling e-commerce, so e-commerce as in, suppose if I search for a particular mobile, so mobile will be having different variation and different pricing and different attributes. It holds different attributes. So those attributes will be stored in this database. And since I'm fetching through the like when some websites, so definitely there would be API called, and it will be hitting this DynamoDB. So this is like that only, right? It's like for fast retrieval, we are using this DynamoDB.
Yes, kind of. You can say yes. It's very fast actually. I mean that this is what AWS claims.
Okay. In terms of use cases, this kind of use cases only is there when we are having a different attribute, plus when we are calling an API and trying to have a transaction immediately.
Yes, and again, just giving a hint there. NoSQL databases, most of them does not support your groups, joins, and some other features because they are not built for that. Because how will you join it? Because how will you create a data model here? Because you have varying columns. Okay, so these things. So you are getting it now. Okay. Reporting purpose, analytical purpose, your query processing purpose, it is not built. It is built for your data storage purpose, but for your NoSQL use cases. Actually, let's see it a bit practically. So let's just go ahead and launch a DynamoDB. What is this? Let me just restart the browser. What is this? Looks like AWS is having some issues here. Let me again refresh this. We want to connect with DynamoDB. This is what how DynamoDB console looks like, and then we have tables here. Okay, so here you can actually go ahead and create table. So to create table, you have to simply say create, click on create table. And then we have to choose a table name. So let's say table. Okay, we have to choose a partition key. So basically, okay, I will explain you later only. We can choose a partition key. Let's say we create a partition key with ID, and let me choose it number. Short keys we are going to understand later, and right now I'm just going to use default settings because I still have to explain you the this capacity mode, the RCUs, WCUs, and all those things. So quickly create this table, and we are going to create it again with some, without default options. Table creation is free. It's not chargeable. In DynamoDB, we get charged based on some RCUs and WCUs. Basically, how much capacity we use for our read and write purpose. And some part of it's free for a few months. So if I go inside my table, this is how it looks like, and you have to call explore table items. Then if you see, let me actually create some records here. So if you come inside here, item returned is 0 because we have no data here. Let me create an item here. Item means I am adding a row into my table. So we have DynamoDB available. We created a table, and now I want to add some data into this. So row is the data. ID is mandatory. It is partition key, or you can also call it primary key. Okay. Its value is 0. We cannot have any duplicate primary key or partition key in any table. Then I am just going to add new attribute. Let's say I added a type of string and I call it name. And let's say we call our name as, let's say, some random name. Okay. And I might go ahead and add one more column, and I can call it last name. And let's just give some random value here. And I'm just going to add one more column, and let it be a number type, and it is age. Let's say I give 30, and I'm going to hit create item. It is created. Let's actually create one more item. Partition key, actually it can be 0. It's going to give me an error because 0 already exists. So we have to make it 1. I'm going to add attribute. So I'm just going to call it no, earlier we created name and last name. Let's say we call it first name, and some name I gave here. Okay, I don't have any age column for this, and I create this item. So if you see here, if I make a full screen and if I select all the columns, yes, they are selected. So you can see this 0 column has 0 row has age, last name and name. Sorry, age, last name and name. These 3 values it has, and it does not even have the columns also of this first name. This row number 1 has first name column. You might feel like it is, yes, it is there, it just to have null storing. But if I go inside this record, right now my view is form view. If I click on JSON view, so this is how actually DynamoDB stores data. It stores the data in a JSON format, or if you understand Python, you can also call it a dictionary format. Okay, like that it stores the data. Eventually it is a JSON format only, not a dictionary, but you can relate this with a dictionary in the key value pairs. So every item that we store inside DynamoDB is basically a JSON document stored, and that has some values about that in a key value format. So if you see, we have ID, age, last name and name columns created for this particular value or this particular primary key. And if I come back from here and go into this one, and if I click on JSON view, I only have this these 2 columns. So this is how we can have a NoSQL database or NoSQL table that is having different columns for different rows, because it's completely separate JSON documents are getting stored one after one in your table. Okay, so I'll just actually stop here because if I go ahead and more, and it might be much more confusing for you. So if you have any doubt or questions here.
Yeah, Jalas. For the actually in the DynamoDB, the creating or importing the data is the only manual, or is there any like using?
No, obviously it can't be manual because you are having millions of records. You cannot have
Right.
a like yeah. So it mostly can connect it with your web front APIs, or you can have a data loaded into or S3 and loaded from S3 also. Many ways are there.
I did not understand. Can you explain in detail how you will import the data? Like in S3, directly there is option like importing data using the file or lambda
See,
push trigger.
actually, we can import data into DynamoDB also from S3. Okay, that option is also there. And we can also connect this DynamoDB with our web front APS. So if I like say this is my console and I'm filling some form here that directly can be connected with your DynamoDB that is entering in this table and reading from this table. So those games and all those e-commerce that we're talking about, those actually connect directly with they connect directly with your DynamoDB.
But here we are not using any connectors, like how those third-party tools will be
We
connected.
have that option. No, we have that option. That's what I'm saying. Maybe we are not using it right now, but we have that option.
Like, but here we did not see any console for the Python scripts using the like Snowflake connector like that to connect using that JDBC or any sources like where we'll implement in the DynamoDB.
First of all, you can import from S3. You can create X clusters, and you can definitely connect it with. I mean, I haven't connected it, but definitely it is doable. I'll have to search for that, but it's definitely doable. It's not like that you have to import or create the records manually. That is definitely
Right.
okay.
Yeah.
And this DynamoDB can directly connect with your Lambda functions, glues, Redshift, like that also, using IAM roles only. So no need of connectors there also. So if I give you one example, my project is using DynamoDB, not an actual use case, you can say. But we guys are just using this DynamoDB for logging purpose. We are using this for logging purpose. Whatever, let's say we are running around 200 jobs every day. So what was their status, whether they started, when they got triggered, how many records they processed, if they failed, what was the issue? Is it a recurring issue? Those kind of analysis we are having in our DynamoDB systems. And we have connected our DynamoDB using Glue. So, and that is actually we are also going to do in our final project. We are going to connect our Glue services like that. Say in the same way, we are also going to connect our DynamoDB. So if you see this job status table, actually I have this table. I just forgot about this. So if you see if I click explore items here, you can see I have triggered this job on various of dates and file date, file month, and how many records it processed. So you can see those details here. Status, failed, completed, all those things you will see here.
So to connect the external third-party tools, then we have to create a cluster and we'll connect through the clusters
No, I'm not saying this. These text clusters are a kind of a caching way of DynamoDB. So whenever you're using the same query again and again, so instead of hitting the DynamoDB tables, it just gets you the result from the cache memory. So no, it does not scan the tables. It just gets you the result from the cache memory.
Okay. In the DynamoDB also there is a SQL is there any editing tool?
Yes, it's particular.
Okay. Here we can use the script, right? So
Yes.
data import or copy in or
So here you can actually do yes, selecting and all those things. And yes, as I mentioned, the joins and all those things it does not support.
Oh,
Actually,
okay.
no SQL database support. No SQL databases does not maybe some of might be one or two might support, but most of them does not work with these features.
Here in DynamoDB, there is no.
That
Here there is no Spark engine, right? This is not attached to any Spark engine.
DynamoDB is in its own features, its own capacity, its own way of storing and working.
Oh, okay, got it. Okay. I think probably we can import the data most of the times from S3.
Yes,
where in the AWS cloud.
Yes, and for that we can write a lambda functions to import data into DynamoDB table from S3. So whenever the file comes on S3, and we can just simply trigger it and upload that into a DynamoDB.
Okay. To connect the third-party tools, we can use the IAM roles, and I mean instead of access keys, we can connect through. Is it JDBC kind of database connection?
See, I'll be frank on this side. I've never made a connection with a front end to DynamoDB, but it is doable. How we can do it? That's I can explore and get back to you.
Okay.
Because I have never worked on the website development, so that's why I have no idea. But yes, we can definitely connect it.
Okay.
Yes, if you have any more questions. Okay, in that case, if you see here, let's actually use this table only. In that case, if I just click on explore table items, we have two options available here. Okay, first option is scan and second option is query. So the difference between scan and query is when I do scan, it reads through complete JSON document that we have stored on our table. Okay, I have shown you a JSON document. So it reads through the complete JSON document when I do a scan. But by default, index is created. You know, the way normal databases creates index on the rows, the same way index is created for your primary key. Okay, so if I do a index based search, so if you see on scan, what filters I have filters of attribute name I can type, and I can type the condition and its value. So let's say my attribute name is name. Okay, I type my name here. Type is string. I am saying equal to, and I'm copying this value and I am pasting it here. Okay, or maybe if I just do run here, it consumed 0.5 capacity and returned me 4 items. Okay, it is actually indexed. Okay, if I just do same thing on end time, attribute name is end time and my value, let me actually just copy it, and again let's just copy it. Actually it's a small table, and if I it's not it's actually a timestamp. Let me actually copy it on file day. I want to show you the difference between scan and query results. I mean, results are not going to different, just the use case. So it's actually, we have a very small table. That's why it's using just read capacity units. It's actually, this is the important thing here. It is using 0.5 of capacity. Okay, 0.5 read capacity units we are consuming here. And actually on DynamoDB, we get charged based on read capacity units only. So if I refer this with a heavy tables, if I do scan on my table attributes like this, I have shown you, it is going to read my complete table first. All the JSON documents is going to read, and then it's going to filter my results with the values that I'm providing. So obviously it's going to read more data, and then it's filtering. And obviously it does not have indexes created over these attributes. Okay, and that is also going to add up more capacity consumed. But on the other hand, if I use query way of filtering, you can see I can only like there's no option I have to provide my column name. It's only already have selected the name, which is my partition key, which is indexed by default, and then my short key, which is created it, that is also indexed by default. Okay. So if I do query here, it is going to filter first, then read my data. Okay, and also it's going to utilize the benefits of index, and that's when my capacity units consumed are going to be very much less. So if I talk about my current DynamoDB that I have in my real-time project, if I do scan, okay, if I do scan on some of the random columns, it might take 600 to 700 read capacity units for that particular thing. And if I do query, it might just get finished in 21 and 22 read capacity units. So it's a difference of 30 times at least, and it is 30 times less I am going to pay if I use query. So this is the difference between scan versus query. Scan does not sorry, scan can filter your records or your tables on each and every column. Scan does not work using indexes. Scan does not filter first. It scans the complete data, then it filters. On the other hand, query you can use only those columns which are indexed in your table. That is your primary table, a primary key, and your short key. Okay, so only these two columns you can use for filtering. Here it filters first, it is more efficient, and it is more quick also, and obviously it is more less chargeable to us also. This is also a difference. So this is what we have on our PPT. Next, I wanted to show you practically. This is the difference between scan versus query. So as per the original information provided by DynamoDB documentation, it says a query will rely on the primary key to find information. Query can point directly to particular item and retrieve the items in fast and efficient way. This is what query is doing for you. Scan, as the name suggests, will browse the table items and from start to finish, and then it is going to filter for you. Obviously, it's not a very efficient way. It's going to cost you a bit more. So if you want to save your cost, if you want to get a faster results, use query. Build your indexes wisely and use query here. So yes, if you have any questions. No questions? Okay. So we have learned that query is efficient way of querying our table in DynamoDB. And I mentioned that it can only be used like filter can only be applied on your primary key and your short key. But what if you want more columns to be utilized in the query? We might have a very big table. We might want to filter that table based on our different columns, and we know that already, like while creating of the table and or maybe after the creation of the table, we know that we can use more columns and we can save some cost by reducing the need of this read capacity units using the query method of filtering the results or getting the rows back. So here we have the feature called secondary indexes in DynamoDB. So that we are going to perform on this our table only. So if you see, we have these features of indexes. So we have actually two kinds of indexes on our DynamoDB table. First one is secondary indexes, as I explained. It is a way of adding more columns to be made available for the querying purpose. Okay, so to do not use scan, we use query, and we have more columns, and we are going to use less read capacity units. Okay, then we have two kind of secondary indexing. First is local secondary index. Here we can use like we cannot change the partition key. Our partition key is going to be same as the table's partition key. We can just add more short keys to our local secondary index. Local secondary index only uses the capacity that is given to your DynamoDB table. Okay, and it cannot be created once your DynamoDB table is created. Okay, it can only be created at the time of DynamoDB table creation time. Once your table is created, you have clicked on the create table, you cannot go ahead and create local secondary indexes. So if you see here on my AWS screen, in the indexes, I just have the option of global secondary indexes. I do not have the option of local secondary indexes. Okay, so if I come back here, and actually let's just go and create one more table. Okay, one more table we are going to create. Demo. I'm going to call it. My partition key is again going to be ID. I'm not going to add short key again. And this time we are going to go through the table settings one by one. I'm going to click on customize settings. So first option is table class. So like we have the storage classes in S3, same way we have storage classes in DynamoDB also. So we can use DynamoDB standard class, and we can use DynamoDB standard infrequent access class. Obviously, standard class needs more storage cost, and it will be less chargeable when you are going to do a read or write. On the standard IA, it is recommended for the tables when you do not read or write very frequently in your tables, and you want to still want to use the NoSQL databases and want to pay a bit less charges. So when your data is when you know that I'm just going to use this table for storing my data, I'm not going to make a very frequent reads and writes here. In those scenarios, we can definitely use the feature of DynamoDB standard IE, that is infrequent access. Then you have capacity calculator. If you want, you can use this. It's actually very simple to use. It just gives you hints how much read capacity units and write capacity units you will need. So if you see, if your average item size is 1 KB, that means the record that I saved, it is a 1 KB of size, and I want to read one record in one time, and I want to read write one record at one time, then I will be needing one read capacity units. Let's say I want to read 100 records. My record size is 2 KB, and I want to read 100 records per second. Then I will be needing 50 read capacity units, and I will be reading 2 write capacity units. Okay, and this is the consistency. I want read consistency to be maybe it could be eventually consistent, strongly consistent, and or it could be transitional. We are going to talk about this also. The consistency mode in the DynamoDB, that is very important piece. Strongly consistent, if I select this, it's just going to get doubled. Okay, my read capacity units required are going to get doubled, and my obviously my estimated monthly cost is also going to be doubled. So I'm just going to stay with eventually consistent, and I'm just fine with I'm actually fine with without this calculator. If you want, you can use this, and same way we have our standard and transitional consistency in our write mode. Okay, and then we have capacity mode, on demand and provisioned. So provisioned means you have provisioned, that means you have purchased the RCUs and WCUs. From now onwards, I'm just going to call it read capacity units to RCUs and write to WCUs. So let's say we know that we need around 50-50 of both, like we need 50 WCUs and 50 RCUs. In that case, we just might go ahead and use the provisioned way of it's like kind of we have reserved this much capacity for our table. Whether we use it or not use it, we are going to pay the amount to AWS. In the on demand, nothing is, if you see, no capacity it's asking to us. If we use more, then we pay more. It's like that. So it's, if we use more, then we pay more with the provision. If you do not use, still you pay. So I'm just going to go on with on demand because my use case is bit less. I'm even if I forget about this table in the on demand mode, okay, even I forget about this table, still I'm not going to get charged for this. Is it clear? The capacity mode? Or if someone has any questions about this.
No, I don't have any questions in this.
Okay. I hope it is same with everyone. If you still have questions, please interrupt me and ask me. Okay. And then if you see, we have the options of local index and global index. So again, referring to back to our query part, scan versus query part. Let's say we already know that we are creating this table, and this table is going to have these columns. And on these columns, we want to have our local index created, or might be secondary index created. As I mentioned, local index can only be created at this particular moment. Once I go ahead and create this table, I won't be able to create any local index on this. So let's see how to create a local index. I'm just going to say click on local index. As I mentioned, we do not have the option of choosing the partition key here. Okay, I just can choose my short key. Let's say after ID, I also want to short maybe on created date. Okay, I want to short it on created date, and it's a kind of a string. Okay, and my index name, I'm going to give create date index. Then attribute projection. So when you query on this new index, you want to return all columns of the table, you want to return only the keys of the table, or you want to include some of the columns. So if you say include, you can give the column names which you want to get in your final result. So if you remember, when I did a query previously, I got all the columns returned in my result set. Okay, same I'm going to use here also, but just in case if you want to filter out the results when you query on your secondary indexes, you can filter it from here. So keys are only going to return you the keys, that means your primary keys and your short keys. Include means you can you are going to have the you are also can have non-keys columns, and you can mention those here. Okay, I'm just going to say create index. It's this simple way. Okay, it's that easy, and this is done. Let's say I also want to add a global index right here. So see the difference, like it will be easy to capture the difference. So if I click on create global index, now if you see, one option is added here. I have my partition also available. So either I can choose the same partition key, or I can create a different partition at all. I can say city. I can say, or maybe I can create my partition based on state, and then I might have my city details. Okay, and my index name will become state city index, and then same option I have here. Then I'm going to click on create index. Okay, so like this, I have created my local index and my global index. Again, repeating, these are the indexes that we can use to query our data set to get back the results. In comparison to scan, query works more efficiently. It takes less amount of RCUs. That means it takes less amount of compute, and that means it takes less dollars from our pocket. Okay. Then encryption settings we can mention, and we can mention deletion protection. This means if you turn on this, if you want to delete this table, it will be asking you two times. It will ask you to confirm the deletion. I am just going to hit the create table. Before this, if you have any questions, please do let me know. Okay, if we have no questions, then let me just hit the create table. Which is requirements where it is throwing the error. If I go in my local, it is having everything as I expect. Okay, is it asking me to create short key? If I hit create again, okay, it worked. Okay, so then if you see, we have this table created. Okay, and now if I go on explore table items, either I can use scan, that is the worst option if you want to query your data. Okay, and then I can come on query part, and now I have multiple options here. So if you see select a table or index, right now it has selected my main table. Okay, it's going to use my ID as a partition key and my date as a short key. Okay, these columns I can use in my query filter now, ID and date. If I want to use my index, I can simply use my local index. In this way, my ID is going to same, but now I can reshort on my create date, and then either I can also use my state and city. So I can partition I can use my primary key as a state, and I can use my city column as a short key column. So like this, I can have my many indexes created. Okay, many columns can be added here, and I can query my table based on this kind of features. So this is all from my end for today. We have started with the DynamoDB. We are still left with a we are still left to understand consistency mode, global tables, and table class we have seen actually, and DynamoDB DAX cluster, DynamoDB streams. What is this? So we are going to see some more features of DynamoDB. And if you see here, DynamoDB, if I go on my tables, so like if I open this table, we have indexes, we have seen monitor, we are going to see global tables, backups, exports, and streams, and these settings we are going to see in next 1 or 2 classes. So if you have any questions, please let me know. Otherwise, that's all from my end for today. Okay, in that case, that's all. Thank you guys. Thank you for joining.
Thank you.
Yes, Pravas, are you asking something?
No, I'm just saying thank you.
Okay, thank you. Bye-bye.
Thank you.
Thank you, Rama.